Welcome back to the deep dive. Usually when we talk about high-stakes documents, we're thinking international treaties or maybe, I don't know, a Declaration of Independence.
Right. Things with wax seals.
Exactly. Things that change history. But today, we are looking at a stack of construction safety requirements.
Sounds thrilling, doesn't it? I can just hear the listeners checking their volume already.
I know. On the surface, it sounds like the driest thing you could possibly imagine. A PDF full of rules about hard hats and steel-toed boots. But, and this is why I really wanted to cover this, when you actually read these documents, specifically the employer requirements E2.0, E2.1, and E2.2, you realize you're not looking at a rule book.
Oh, not at all.
You're looking at a code for predicting the future.
That is a really strong way to frame it.
Well, am I wrong? It feels like an operating system designed to stop reality from going wrong. It's almost like sci-fi in its ambition.
You're not wrong. In fact, if you take one thing away from this deep dive, it should be that modern safety isn't just about being careful. It's a rigorous engineering discipline.
Okay.
We're looking at a massive project here, and these documents, they show how they plan to move from basic compliance, just following the law, to what they call a generative culture.
A generative culture. That sounds like corporate buzzword bingo.
It does, doesn't it? But in this context, it means a culture where safety isn't enforced from the top down. It's generated from the bottom up.
Okay, unpack that.
Well, it's the difference between a police officer watching you so you don't speed and you simply being a safe driver because you understand the physics of the car and, value your life.
Right, that I can get behind. So let's get into the architecture of this thing. We have three main documents we're unpacking. E2.0 is the big picture, the HSE requirement.
That's the foundation.
Then E2.1 is the life-saving rules, the non-negotiables. And E2.2 is the site rules, all the logistics.
Correct. And E2.0 really, it sets the whole stage. It lays out the rules of engagement.
And the first thing that jumped out at me in E2.0 is the sheer responsibility they put on the contractor. The employer doesn't just hand over a manual and say, follow page 5. They say you have to build your own engine.
Exactly. The requirement is for the contractor to develop their own HSE Management System, or MSGRAT. It has to comply with the employer's principles, sure, but the contractor has to own it.
Right.
It stops that passive, just tell me what to do mindset. If you're the contractor, you have to prove you understand the risks well enough to write your own plan. It just changes the dynamic completely.
And they are incredibly specific about who has to lead that plan. This isn't something you can delegate to a safety officer while you sit in the trailer with the AC on.
No.
The document really goes after what I'd call absentee landlords in management.
Oh, it's brutal on that front. It explicitly states that senior management, so project directors, construction managers, they must be visible. They can't just sign a policy and then vanish.
I noted that. It lists specific behaviors. Personally intervening when they see unsafe acts, doing regular management walkarounds, and actually chairing the HSE meetings. It feels like they're trying to force leaders to get their boots dirty.
It's about felt leadership. If the workers see the big boss wearing the PTE correctly and actually stopping to check a scaffold, it sends a signal that's so much louder than any memo.
It makes it real.
It validates that HSE is a core value. If the boss doesn't care, why should the guy wielding the hammer?
Okay, this leads to a concept in E2.0 that I found really difficult to wrap my head around. The blame-free culture.
Ah, yes. This is always the friction point.
It just sounds so counterintuitive. We're talking about life and death environments. If someone screws up, shouldn't there be blame? Shouldn't there be punishment? But the document says for reporting, non-conformances, near misses, you need a blame-free environment.
Okay, but think about the goal. The goal isn't justice. The goal is data. If I punish you every time you report a near miss, say, you almost dropped a lunge from height, but you caught it, are you going to tell me about it next time?
Absolutely not. I keep my mouth shut and hope nobody saw.
Exactly. And then I, as the manager, I lose that data point. I don't know that our tissues are slippery or that the gloves are failing. The blame-free culture is a data-gathering strategy.
So it's not about being soft. It's about being smart.
Precisely. They are chasing a specific metric here, a TRCF, or Total Reportable Case Frequency.
Which is?
It's the number of recordable incidents per million man-hours worked. The target is less than 2.0. To get that low, which is world-class, by the way, you need to know about every single tiny crack in the system before it becomes a break.
And you only get that if people aren't terrified of losing their jobs for raising their hands.
You got it. It's
Right.
Psychological safety enabling physical safety.
That's actually really profound.
But, and here's the nuance, It is not a consequence-free culture. There is a line. And we'll get to that when we talk about the life-saving rules. But for the management system, they want transparency over fear.
Okay, so that's the culture. Now let's talk about the crystal ball, the prediction part. There's this acronym that pops up constantly in these documents, HEMP.
HEMP, Hazards and Effects Management Process.
Which sounds like a gardening seminar.
A little bit, yeah.
But in this context, it's actually the core risk engine, isn't it?
It is. HEMP is the methodology for looking at a project and asking what is going to kill us, and then engineering that possibility out of existence. It uses a tool called the Risk Assessment Matrix, or RAM.
Right. I've seen these. It's a grid, right? Likelihood on one axis, consequence on the other.
Right. And depending on where a task lands on that grid, low, medium, or high risk, the rules change. Low risk, basic competence, maybe a quick chat, but high risk, that is where the system really clamps down.
The document mentions that high-risk tasks require a detailed analysis, sometimes using the bow tie methodology. Can you break that down? Because I'm just picturing a tuxedo.
Aye, okay. So picture a bow tie. The knot in the center is the top event, the bad thing happening, like a gas leak.
Got it.
On the left side of the knot, you list all the threats that could cause it. Corrosion, valve failure, human error. And you put barriers in place to stop them. That's your prevention.
And on the right side?
The right side is recovery. The knot has untied. The leak has happened. Now, what barriers do we have to stop it from becoming a catastrophe? Fire suppression, evacuation plans, emergency showers.
Wow.
HEMP forces you to map out both sides of that knot prevention and recovery before you even pick up a tool.
That seems incredibly thorough. It's basically writing a script for every possible disaster. But there's another concept here that I think is the star of the show, LRP.
Yeah.
As low as reasonably practicable.
This is the golden rule of safety engineering. This philosophy governs everything.
But isn't reasonably practicable a bit vague? It sounds like a loophole. Oh, it wasn't reasonably practicable to buy the expensive safety gear, so we didn't.
It sounds that way, I know. But in legal and engineering terms, it's actually a very strict test. It asks the question, how safe is safe enough? You can never eliminate 100% of risk unless you just stay in bed. So ALAW-RP is the process of reducing risk until the cost or effort of reducing it further is grossly disproportionate to the benefit.
The document actually outlines a test for this called the one step too far test. I loved this. It felt like a logic puzzle.
It's a great mental model. You look at your options to make a job safer. Option A, use a ladder. Option B, use a scaffold. Option C, build a permanent staircase.
Okay.
You keep upgrading your safety measures until you hit an option that is clearly one step too far, where the cost is astronomical or the time delay is massive compared to the tiny bit of extra safety you gain.
So if a scaffold is 99% safe and costs $500, and a permanent staircase is 99.1% safe but costs $50,000?
Then the staircase is one step too far. You stop at the scaffold. But, and this is critical, the rule is if you are unsure, if the math is fuzzy, you always lean towards more safety. You assume you haven't gone far enough yet.
So the default setting is always safety first until it's proven impossible.
Always. You don't get to gamble with other people's lives.
Okay, so that's the high-level engineering. But how does this filter down to the guy or girl with the wrench? I mean, they're not doing a bow tie analysis at 6 a.m. in the rain.
No, they're not. And that's why E2.0 mandates toolbox tactics. These are mental shortcuts designed to sort of download that high-level engineering into the worker's brain. The document mentions the 3 whats.
Which are?
What can go wrong, what can cause it to go wrong, and what can be done to prevent it.
Simple.
Deceptively simple. It forces the brain out of autopilot. If you can't answer those 3 questions, you don't start the job. The other one is the step back 5.
Take 5 minutes before you start.
Literally, physically step back from the job. Look at the whole workspace. It breaks your tunnel vision. We are creatures of habit. We see what we expect to see. The step back 5 is a hack to force your brain to reevaluate reality and spot the hazard you missed.
Okay, let's move on. We talked about the management system and risk assessment. Now let's talk about the hard lines. Document E2.1, the life-saving rules.
These are different. The management system allows for some adaptation. The life-saving rules do not. The document is explicit. They must be adopted as written. No modifying, no watering them down.
Why so rigid? Why not let the contractor adapt these too?
Because these 9 rules, they cover the activities that historically kill the most people on these kinds of projects. It's about standardization. If a welder moves from site A to site B, work at height needs to mean exactly the same thing.
You can't have different dialects when you're talking about survival.
Precisely.
So let's look at a few of these. Bypassing safety controls. This one seems huge.
It is. This rule says you cannot override, disable, or, tape over a safety device like a sensor, a valve, a guard without specific authorization.
We've all seen it done. The sensor keeps beeping. It's annoying, so someone puts duct tape over it.
And that is how disasters happen. That sensor is the voice of the machine telling you something is wrong. Silencing it is like taking the batteries out of your smoke detector because you burned toast and then going to sleep. It's forbidden.
Then there's driving. It seems so mundane compared to cranes and welding, but the rules here are incredibly strict. No phones, seatbelts always, speed limits.
Because statistics don't lie. Driving is often the single highest risk on a large project. You are more likely to die in a car accident going to or from the site than falling off a scaffold.
Wow.
Yeah. So the life-saving rules treat a pickup truck with the same respect as a high-pressure pipeline.
And speaking of scaffolds, working at height, the rule is 100% tie-off.
That means there is never a millisecond where you are not attached to the structure. If you're moving from point A to point B, you use a double lanyard like a lobster claw. You hook the second one before you unhook the first.
So you are never free soloing on a construction site.
Never. Gravity doesn't take breaks.
Now here's where the culture part crashes into the rules part. The document talks about an intervention authority.
This is a fundamental requirement. It states that everyone, from the project director down to the newest 19-year-old subcontractor, is authorized to stop work if they are in doubt.
Authorized. It sounds like they are obligated.
They are. And crucially, the document says they can do this without adverse consequences.
That's a big ask, though. I mean, imagine you're a junior guy and you see a veteran foreman doing something sketchy. It takes a lot of guts to say, hey, stop the crane.
It takes immense courage, and that's why the leadership visibility we talked about earlier is so important. If the bosses don't back up that junior guy, that intervention authority is just ink on paper. The culture has to prove that stopping work is a victory, not a delay.
This brings us back to the blame-free paradox. We said earlier, don't blame people for mistakes. But if I break a life-saving rule, if I don't hook up my harness, surely I get fired.
You would think so.
Yeah.
But E2.1 has this fascinating section on accountability versus conditions. It creates a distinction.
How so?
It says that before you punish the individual, you have to look at the conditions. Did the workplace make it difficult to follow the rule? So, for example, you didn't tie off, okay? But were there anchor points installed with the lanyard the right length? Did anyone train you properly?
Ah, I see. So if the company failed to provide the anchor point, they can't fire you for not using it.
Exactly. You cannot blame the worker for a system failure. That's just scapegoating. Consequence management, which is the polite term for firing people, is a last resort. It's reserved for when the conditions were perfect, the training was clear, the equipment was there, and the individual chose to violate the rule.
That is a surprisingly sophisticated view of human behavior for a construction document. It's basically saying, fix the system first, fix the person second.
That is the definition of a just culture. It ensures that discipline is fair, not reactionary.
All right, let's move to the final segment. We've got the rules, but we have to deal with the messy reality of the actual site. Document E2.2 covers site regulations and the environment.
And this introduces a logistical nightmare. Often, these big projects aren't built in a greenfield. They're built inside existing operating factories or refineries.
So you have the construction team's rules and the factory's existing rules. Who wins?
That's the gray zone. And to fix it, the document requires a bridging document.
A peace treaty.
Basically, the contractor has to analyze their rules against the site's rules, find the gaps, and write a document that bridges them.
So everyone's on the same page.
Exactly. You can't have a crane operator following one rule book and the guy on the ground following another. That's how signals get crossed.
And it's not just about human safety, is it? E2.2 gets very specific about the environment. ISO 14001 compliance.
It does. It covers dust, noise, protecting marine and terrestrial animals. I noticed a specific metric for spills. Any spill greater than 100 kilograms has to be reported as a major incident.
100 kilos, that's what, a decent-sized barrel?
Roughly, yes. It shows they aren't worried about a cup of coffee. They are tracking significant environmental impact. They treat a spill with the same severity as an injury because, in the long run, environmental damage is a safety issue for the community.
There's one specific phase of the project that seems to terrify the authors of these documents. Commissioning.
The commissioning dangers. This is the moment the beast wakes up.
Why is this phase so special?
Because the psychology of the site hasn't caught up with the physics. For 2 years, you've been building a static structure. The pipes are empty, the wires are dead, you can touch things. Then suddenly, during commissioning, you start introducing pressure. You start turning on the electricity.
But the workers are still in construction mode.
Exactly. They walk past a pipe they've walked past 1,000 times, but today it has 100 bars of pressure inside. If a flange blows, it could cut you in half. The danger is invisible.
Yikes. So how do they manage that transition?
The document mandates strict red spade procedures, physical markers, literally bright red spades inserted into pipes for isolation and managing live areas where access is restricted. It's about shocking the workforce into realizing we aren't building it anymore, we are starting it.
And if something does go wrong, if there is a major incident, the document E2.0 requires a specific investigation method. Tripod beta analysis.
Now we're getting into the sci-fi names again.
It sounds like a generic villain's plan. Initiate tripod beta.
It's actually a Dutch methodology. It was developed for the oil and gas industry. Most investigations stop at the immediate cause. Example, he slipped. Solution, tell him to walk better.
Which solves nothing.
Right. Tripod beta forces you to look for latent failures.
Latent failures.
The hidden flaws, the time bombs ticking in the system. So why did he slip? Because there was oil. Why was there oil? Because a seal leaked. Why did the seal leak? Because we bought the cheap seals 3 years ago to save money.
So the accident didn't happen today. It happened 3 years ago in a boardroom.
Bingo. Tripod beta connects the guy slipping on the deck to the decision made by the accountant or the designer. It forces the organization to fix the operating system, not just the symptom.
And that brings us full circle. We started this by saying safety isn't a rule book, it's an operating system.
And I think E2.0, 2.1, and 2.2 really prove that. It's a complete loop. You have the blame-free culture to get the data, you have HEMP to analyze the data, you have ALAR to engineer the solutions, and you have the life-saving rules to protect you when the engineering just isn't enough.
It really is an attempt to impose order on chaos. It's impressive.
It's the ultimate engineering challenge. You're trying to engineer human behavior, and that is so much harder than engineering steel.
And frankly, a lot of these tools, Step Back 5, ALRP, seem useful even if you aren't building a refinery.
Absolutely. Is the risk of me driving in the snowstorm as low as reasonably practicable? It's a good question to ask yourself.
I'm going to use that. Sorry, I can't come to dinner. The risk is not ARP.
I'm sure that will go over well with your friends.
I want to leave the listener with one final thought to chew on, though. We talked about this tension between the blame-free culture and the strict consequence management for breaking rules.
The central paradox.
Right. The documents lay out the rules, but they don't tell you how to navigate the human emotion of it all. How does a leader perfectly balance, I want you to feel safe reporting mistakes, with, I will fire you if you are reckless?
That is the part that can't be written down. You can document the physics, you can document the procedures, but you cannot document judgment. And that is where the human element is still the most critical safety device of all.
A sobering thought. Safety is rules, but ultimately, it's people. Thanks for diving deep with us today.
Stay safe out there.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.